All right. We're reviewing where we were at the end of yesterday's class. So does everyone have this spot? All right. Tell me, Brendan, what was the T standing for?
Period.
All right. So period. When we're talking about the mass spring system, we're putting a mass on the spring and we're pulling it down. One cycle is it goes, you let go of it, it goes up and back down. That's one cycle. So the period is one cycle. And M, Brendan?
It was mass.
And what's K?
Spring constant.
All right. Now sometimes in the problems I'm going to give you, they don't give you K, so you have to go back to this one to get K. And sometimes they don't give you force, so you have to go back to this one and get weight equals mg and use it. So you have to dance on down the line with these sometimes. All right, let me do one example and then I'll give you a couple to try. All right, here we go. Draw what shall we put on our spring? How about a boring old mass? All right, here's the example. We have a regular spring with nothing on it, like that, and we're going to pull it down in the next snapshot. We're going to pull it down 59.1 centimeters. So sketch that as well. This is an example using this formula. So draw that. The mass that has at the bottom is 34.5 kilograms. And then I'm going to pull it down even further. I have to adjust my drawing. I ran out of board space. Here's my spring, unchanged. Then I'm going to stretch it down. Same problem, I'm just redrawing, 34.5 kilograms. So when I stretched, that mass stretched it down 59.1 centimeters. And now I'm going to take it, it's just hanging there just like that mass, and I'm going to take it and pull it down further. So when I pull it the next time, it goes an additional 35 centimeters. And that's the scenario. So then I'm going to let it go from that point. So here's the spring. When you put the mass on it, it naturally pulls it down to there. Then I'm going to pull it down even further and let go.
So, yeah, that's good.
The question is, find the period of this bounce. So it's going to create a spring motion, find its period. So we grab the formula from right up here, and when we do that we get T equals 2 pi square root of m over k. So we're looking for T, 2 pi. The mass of the system is 34.5, so that goes under the square root. And we have to go somewhere else to find K. Where? Where do I go to find K on this one? Hannah?
Excuse me, weight equals mg.
Well, that will give you K. We might need that to get K.
But that's what you use to plug in for F in the F.
Right, so we're going up here first. And you're right, we're going to end up over here. So we have to find K, and this equation has K in it. So I'm going to put F equals negative Kx. We have to find the mass's weight. That goes in for force. So now we're over here. So Hannah, if we put in 34.5 for the mass and 9.8 for G, what is weight? Just give me two sig figs.
340.
340. Did you?
That's what I got.
Did I? Did I do that part? 340 or 350?
340.
Really?
340.
340? Okay, I don't know why I ended up. So the mass from this calculation, I'm sorry, the weight is 340. Alright, so going back into my period equation, I'll replace mass with 340. And now K is, we're ready to go up here. Oh, I'm sorry, mass
Oh, wait.
one. You're right, I'm sorry, that does it. The mass is mass. I substituted it in the wrong place. Alright. This goes up here, not down there. Alright, so I'm going to put in 340 for the force, because I cannot use the mass there. And so I went over and figured it out. What is the question that students mess up on a lot on these is the proper X. Can you look at it and find which one of these distances, is it this one or this one? When I'm finding the spring constant, it's very important. So take a second and look at it and think in your mind, is this equation asking for this? So I'm going to put that in the green spot or this one? Which one? Hannah, what do you think?
This is the 59.1.
And why?
Because it's when it's just hanging.
Right, because we want to know how strong the spring is. And this involves my hand pulling it down. So this is where you go to find the spring constant. You want to know the distance that this spring stretched all by its lonesome when this mass was hung on it. So I'm going to put in the 59.1. I can't use centimeters, so we have to change it to we never use centimeters, 0.591. All right, tippy tap, I need some decimals. Can you get that one for me, Abby? And this X went downward, so it's going to give us a positive K. 340. It's a big one, isn't it?
Yeah, I got negative 575.3.
So in 2 sig figs.
So 5. What? I could just do 570. Or
Pardon?
do you want me to do in the scientific?
Oh, 570? Okay. I didn't go up to 580. It was 570.
Isn't 75 round
It's
up to
580.
80?
Was it, what was this
It's
digit?
75.
What was this digit here?
5. So it rounds up.
Alright, so that will bump that up. Yeah, so this is 2 figs, or you could write 2 sig figs, or you could write 5.8 times 10 to the 2. And what is the unit for K? If you look back in your notes, it's newtons per meter? Yeah, newtons per meter. Alright, so now we're finally ready to find the period. That goes in down here. So the 580 goes down here, so tap away.
You put it in this negative?
No, it's not negative because this is negative and this is negative.
Oh, okay.
So it's a positive K. Alright, so go ahead and tap away. 2 pi. Let me just look over your shoulder, see if you're able to handle that square root on your calculator. You're going to have to use parentheses. Get one.
Where?
You're going to have to use parentheses under the radical.
Does anyone else need one?
Pardon?
I was asking if anyone else.
Oh yeah, should be in terms of
In
pi.
terms of pi or no? 'Cause I
Um,
got that little tiny answer.
yeah, I just went ahead and it's in seconds. Let's get rid of the pi.
So you do multiply by pi?
Yeah. Yeah. Good. And put a unit there. What would be the unit for period?
Seconds, right?
How long did it go?
Seconds, yeah.
Good. Alright, I want to see everyone else's, but some people are finished up, so I'll be by. I just want to give you the problem sheet so you can work out a couple more. And I'll shine on this on for Molly in a minute.
I have 1.5. I don't know how to do this. I'll just do it. Okay, so
Did you get one yet?
Still
Not yet.
writing
And then I would
So
put
I
another
heard.
parentheses just to be
Good.
safe.
And then just put a unit on there. What's the unit for period? It's a how long
Or
question.
divided by
There you go.
580. Okay, yeah, and then multiply that
Yes.
by 2 pi.
And is this homework?
No, we're working on it right now, for a few minutes anyway. What'd you get?
I feel like I have to triple sometimes. 'Cause, like,
Tippy tap again.
easy to get from to- I always miss it.
All right, Molly, here's the worksheet that we're using to practice these problems on period. So, oh yeah, turn the light out, so take you on a little trip here.
Yes, I can.
All right, while you're working on this, I'll hand out the Fat Friday. It's ice cream. That's not very clear, is it?
Do I have a flashlight?
No, actually, the less light, the better. All right, I think you can read that, Molly. That's number 1. Here's number 2.
Every single time.
That went across. That went across the air.
I have hiccups and I keep coughing.
Do you need to get some water?
No.
Oh, so it's synchronized.
Number
Yeah.
3. It's 3 problems. All right, Molly, over and out for a few.